circular target with a diameter of 1 meter. What's the probability that a dart thrown will land in the bullseye? This is an area problem, so we are going to take the area of the bullseye and divide that by the area of the entire target. Alright, well the bullseye is a circle and so is the target, so it's pi r squared divided by pi r squared. But there's a problem. One's in centimeters, one's in meters. So the first thing that you will need to do is convert. And it's much easier to convert meters to centimeters. So the diameter of the circular target is 100 meters. And let's see if we can take a shortcut. Don't we have a perimeter ratio and an area ratio? What is the scale factor of these two circles? Remember, a scale factor can be found by comparing two similar or two corresponding parts. Well, I know the diameter of both. Then I can compare them to each other. And remember that all ratios are in lowest terms, so that means that this reduces to 1 to 20. Well, if that's the scale factor, the area ratio is the probability that it will hit in the bullseye, because it's the bullseye area compared to the target area in simplest terms. And how do we find an area ratio? We square both terms. So our probability would be 1 in 400. Finally, this is my own little made-up problem. You have a field surrounded, it's a rectangular field surrounded with fence that's 30 feet by 50 feet. And in the center is a little track and field person. We'll say Hercules. And he's going to be throwing the discus. Now, if anybody's ever seen this happen, you turn in circles and you let go. But Hercules is not sure where to let go. He just knows he's going to be spinning in circles and he's going to let go of this thing. Now, Hercules can throw the discus 30 feet. Since he can throw it 30 feet, that pretty much means it's going through a fence somewhere. So my question to you is, what is the probability that the disc will crash through the south fence? Well, this is a linear problem. It's not area because we're simply talking about the fence. So if it's linear, we need to know the length of the south fence, and we need to divide that basically, because he is going to spin around in a circle and we're not sure where he's going to let it go, by the entire perimeter. Well, the length of the south fence is 30 feet, and the entire perimeter is 50 plus 50 plus 30 plus 30, which would be 160. And remember that all ratios must be reduced to lowest terms. So when we reduce, we get 3 over 16. And that is our probability that the south fence will be destroyed by Hercules. Okay? I think that's all I've got for you. Those are types of problems. Those are things that you need to know. How to set up geometric probability and your area perimeter ratios, how they're related to each other, and how to use them. Tests tomorrow. Good luck. See you there.